welcome everyone here and online for this Breakfast on Science. It's always a pleasure to be in a Breakfast on Science for me. And today I'm very pleased to host my colleague and friend, Delphine Ribes. For those that you don't know her, she has a background in electrical engineering from Lyon, and she did already her master thesis specialized in medical image analysis here at the EPFL. Then in 2008, she joined the Siemens Healthineers group here actually at CIBM, where she was working already at the forefront of developing technologies, and she was specializing in MRI, brain, morphobox. Maybe you heard about it on the quantification of brain tissues. These are actually today product. And then she moved in 2013 or 11, she moved to the RDoc. It's a center of engineering at the University of Bern, where she was in there working with image-guided therapies for the liver, as well at the forefront of deploying these in many hospitals, so implementing and deploying, doing clinical trials at the international level. Then she joined the ECAL EPFL group, and she will explain today what is this about. And the idea is that she was gaining a lot of expertise, of course, in doing medical image analysis and in general health engineering solutions, but she quickly understood that it is very important to put the human at the center of those developments if you want to ensure that this is adopted, and that is adopted at the long term in a sustainable manner. So we were very lucky in the MS Explain project that we have on deploying AI solutions for multiple sclerosis to have the ECAL team, so Delphine's team, joining us. We learn a lot. And I think it's one of the projects that she will present today. And we thank you very much for taking the time to presenting your work. Thank you, Delphine.
Thank you, Mary, for this kind introduction. And thank you all for being here and for having me here. So today, I put this title, Beyond Innovation, Design Research Methods for Adoption and Acceptance. And first, I want to introduce you a little bit EPFL ECAL LAB and what we do before we dig into this notion of adoption and acceptance. So, in short, EPFL ECAL LAB is a design research center, and we belong to EPFL, so it's an EPFL center. And it was created a long time ago in 2007 in collaboration with ECAL. And we are actually located in the ECAL building. So the ECAL is the Design School and Art of Lausanne, and it's in Renan. So not too far, but we are not on the EPFL campus. And I mean, our objectives at EPFL ECAL LAB is to bridge science, technology, and societal engagement. So what does this mean, societal engagement, and why we do that, and why we think and we believe it is important for researchers to do that? So it means like involving people beyond academia. So when you create something as a researcher, engage with them, it means like involving them into your research. Like it could be patients, citizens, policymakers, and it's not, you know, you're not just using them as tester, but you really engage them into the research process. Because you want to co-create together. It's not just sharing the results, looks like as a researcher we do, but it's really like create methods that involve them to the whole process. And what is interesting is with them, you kind of address their needs. Sometimes when you work in research, you know, we are a little bit disconnected from what is happening actually in the real world society and in the field. So it helps you to get your feet on the ground. And yeah, the whole idea is also to build trust over time and create a relationship. And this is really important currently, I think, especially like there is a lot of distrust currently with science. So when you get them involved with you, I mean, they are engaged into this process and they believe in it. And yeah, ideally, you create more tangible impact, so something that can be easily translated to the real world. So yeah, why you want to engage with the society? It's a little bit what I said already earlier, but the whole point is to increase the relevance of your research. Somehow, when you know exactly what is required, then your research will have more impact. You enhance accountability, and you improve the understanding of people for your results. And again, you increase your capacity to translate it. Ideally, you increase your chance of adoption and acceptance. I will come back to those terms a little bit later. On another pragmatic way, by engaging with society, it's becoming a requirement when you do apply for funding, and more funding opportunities required for you to do such a thing. So yes, if you want to get money, this is something which gets very important. And you can see it also on the European level. They create a new indicator, which is called the societal readiness levels. So I don't know if you are familiar with those terminology. There is still the TRL, technology readiness level, which was supposed to take into account this part, but was not really taken into account. So that's why they create a new indicators. And now they ask specifically researchers to take care of that. So how we do it at EPFL ECAL LAB? Well, first, we are a pluridisciplinary team. So a bunch of engineers, designers, different type of designs, graphic design, product design, interaction design. There's also people specialized in cognitive science. And we have also people specialized in scenography. So, you know, it's important also to help to translate to the public, to have someone helping you in creating this environment where people can understand what you do. There's also all the admin people and Nicolas Anchaud, who is the executive director of the EPFL ECAL LAB. So our methods, it's nothing magic. It's something that we developed since 2007, I would say. But it is based on something which is very famous, the double diamond. And the idea is that you have different stages in your process, and you apply different methods during the process. And we always start with what we call the immersion phase, because as a design research team, somehow we don't really know what your research is about. So at the beginning, it's very fuzzy, a little bit as you can see in the graph. And the idea with the immersion phase and some methods that you can apply in this immersion phase, you get a little bit more knowledge about the project. What is interesting as you as a researcher in this phase is that, of course, we do some literature review, as every scientist will do, but we also do state-of-the-art, what we call, so we are looking at what exists outside of the research world to know, okay, how the society is coping and dealing with these problematics. And we do also interviews, and we start also already with people who are the expert in the field. And I think it's some methods that every researcher could apply, because even though you publish your results, there's many parts of it that you don't say in those papers. So it's a way to get knowledge from people who've been through this process in a different way. So it's a good way to learn from the experts. And then once we've done this immersion phase, we get a little bit more knowledge about the project. We are able to draw a map of stakeholders. And from that, we will start doing different type of interviews, workshops, etc., to define what is the strategy that should be applied for this project. And then we will start designing. So it could be like the experience, but any type of other thing. And we do it in an interactive manner. So we do cycles, we implement, test. And at the end, we do summative studies where we do like huge collective data, and we do qualitative and quantitative analysis with the help, of course, of our cognitive scientists. So what are the topics that we are addressing at EPFL ECAL LAB? Yes, there is health and well-being, of course. So we believe that health and well-being belongs together. Somehow you cannot be healthy if you don't feel well, and vice versa. And today I'm going to present you one of the projects we are currently running in collaboration with a group of Meritxell. It's about AI and, of course, all the topics of AI and explainability. But we have also other projects which are more relating to well-being, such as meditation and biofeedbacks. We also have a running project on neurofeedback and with the issue of people suffering from tinnitus. We also have topics on environment and sustainability. So if I have time, I will present you also one project about that. And there we have two running European projects. One is on how to conciliate environmental data and nutrition data, because usually they are somehow always viewed in a separate manner, and as a user, it's difficult to understand how to consume in a proper way in terms of nutrition and environment. And we also have a project which is called Mount Resilience about water management. So the idea is how to reconciliate all the stakeholders. So water is a huge resource, and are trying to see how a digital tool can help people to negotiate about water. So if you are, when we talk about water, it's like, for example, farmers need water, citizens need water, policymakers need water. So how they can use this resource in a proper way. We also have topics on the digital heritage and social dynamics. So this is more how to make value out patrimonies. And I mean, it's a project that we liked here at EPFL and ECAL LAB for two reasons, because it's always fun, but also it helps us and it allows us to test initial ideas in the setups which are easier than in the medical field, for example. So, you know, because you don't have all those ethical issues that we all know about. So this is about EPFL and ECAL LAB. And then before we move to more specifically on some project we have, I wanted to give you some definition of what we mean by acceptance and adoption. Well, let me grab some water. So I don't know you, but in my case, when I do develop something or create something or think of something for someone, actually I want the person to use it at the end. Okay, but if I do it by myself and for myself, etc., well, usually I failed. So this is sad, and it's really my engineering art talking here. So that's why actually I joined EPFL and ECAL LAB to learn a little bit of how to do that. But if a person adopts a tool, does it mean I succeed? And if a person accepts a tool, does it mean I succeed? And what you want, what I want, is actually both adoption and acceptance. But actually, what are the differences? So technology acceptance is about attitude and intentions. It means how a user perceives a technology, and it focuses on whether people believe it is useful, easy to use, and worthwhile. So this is when a person accepts the technology. On the contrary, adoption is more about the behavior of the person. So it's the decisions he makes about using a technology. And this can happen at different levels, societal, organizational, and individual. And at the end, it means actual real usage. They integrate it into their daily life. What you can say is that acceptance can lead to adoptions, but it's not always the case. Give me an example. I give you an example to make it easier to understand. I don't know you, but at EPFL, we were forced to use Teams. So yes, we adopted it. It was no choice, but do we accept it? This is another question. In terms of acceptance, typically here I show you an example on the top of some monitoring activities that people, when you do testing with them, they will say, yeah, it's great, it's super, and they accept it, but at the end, they don't use it, so they do not adopt it. So these are really the differences. And what you want ideally, in the ideal world, it's acceptance and adoption. So behind, there is a lot of theory and models. We'll go quickly through it because it's a huge literature. And to be honest, I'm not an expert on it. It's more my colleagues. But I wanted to give you some of the most famous models. This way you have them in mind. The first one is quite an old one. And the very famous one is the diffusion of innovations. And it's a technology adoption life cycle. So it's a theory which explains how new ideas, product, technology spread through a population over time. And it focuses on the society level. So it's not personalized somehow. And it highlights that adoption occurs at a different stage. So there is 5 types of adopter categories. And as I said, it was developed a long time ago. If we look at an example, here it's about smartphones. So, before we got the first iPhone, there were already smartphones existing. I don't know if you remember, for the old people like me, there were the Blackberries. Actually, they were adopted mostly by tech enthusiastic, somehow business executive, developers, which somehow are comfortable with clunky interfaces and high prices. So general public's no interest. And then Apple introduced in 2007 something which is radically different, a large touchscreen, no keyboards, no stylus. And the notion of App Store. So this was radically new. But there was a classic early adopters phase where people were still queuing at the app stores to get really the last product. And this is get exciting. People get excited and there is a social enthusiasm around there. Then there is the early majority of adopters and it accelerates somehow. And because you have more type of more devices, there is more people who are willing to buy it. Also the price goes cheaper. So this is how it works. And then there is the late majority and the laggards. So those are the ones who are forced somehow to use it, a little bit like us with Teams. So we are not very happy about it, but there is no way because for your work, there's 5 characteristics according to these models that predict adoptions compared to a former product. Is that how better it is compared to what exists? This seems very classic. How compatible it is with existing values, experience, and needs. Then how complex it is. So if it's easy to use, there is higher chance that people will adopt it, and how triable you can test it before buying it. This is a very important steps actually. And then social impact is very important. So how people are enthusiastic about this technology that make people will want to adopt it. So if we go back to our example of a smartphone, yes, of course, a smartphone had advantage over previous mobile phones, and they were more and more compatible with what exists, and they became less complex, easier to use, and there were more capacity to use it. And then you could see people using everywhere. And so, by observing people, so, oh, it looks nice. Oh, Google Map, this is a good place, good things to use when I'm getting lost. So we got all our mobile. And then there is other models. I will go a little bit faster on those. There's a technology acceptance models. So it's, again, a kind of an old framework, but it's a theoretical framework predicting how a user might adopt a new technology. And the idea at this age was to create it in the context of work and productivity. And somehow it's not too much looking at the technology, but rather how the technology is perceived. Just here, it's a quick diagram about it. And what's important to them is a perceived usefulness and perceived ease of use. I don't know if, those two. And then it can lead to the intention to use it. So, what is interesting with those models is that it doesn't come just as a model, like that, where, okay, now I use it. But they also provide questionnaires to use it. So when you create a technology, there is already existing questionnaire which has been validated by the community that you can apply. So usually it's like a 5 or 7 point Likert scale. Likert scale, like you get the questions, and then I agree, I completely disagree, I agree, I fully agree. And there is a multiple item per construct. Just this is an example of what you can have as a results and as a questions. So if you look at the first row, if this application was complete and there, I will use it, and then people select. So it gives you somehow a trend on how much people are intend to use this technology. But I mean, those models, are the simplified visions of it. And every model is a simplified version of the world. But the researcher realized, like, okay, it's too simple. There is some missing value in it. And so they increase it and they create the UTOT, so Unified Theory of Acceptance and Use of Technology. And there, the idea of the researcher was to see how such a performance, to add, instead of just performance and perceived usefulness, to add prior models on the social influence and what are the facilitating conditions on the societal level to use it. So there is different construct also in these models. And what is interesting about this model is that it adds more theory to it and models a little bit better the world, but still it doesn't take into account the intraset motivation of the people. So it's more like how util is your technology. So it's really about extrinsic motivation, sorry. So then, again, they increase it, add more constructs, hedonic motivation, so intrinsic motivation, so the fun to use the technology, the price, how important the price is, the habit, and etc. So those are somehow the models which you can use to measure if your technology is going to be adopted and accepted. The thing is, as I say, they are very complicated, and there's a huge list of items that you need your user to fill to get the value out of it. So in our practice, what we do, we select the constructs which make more sense to have shorter questionnaire, because especially in the medical field, medical doctors don't have time to spend 1 hour filling questionnaires. You really need in advance which construct you are interested in and choose the items related to the construct. So this is for the theory, somehow. Now I wanted to present you 2 projects. We'll see if we have time to present the 2 projects. I will start with the first one because it's the one in collaboration with the team of Meritxell. And you probably know it already because I guess you've been presenting it many times. I hope so, because I didn't spend much explaining time explaining uncertainty. So it's about, we call it designing trust. So exploring how explainable AI and how explainable AI is presented. So explainable AI in radiology. As I say, it's a project in collaboration with Meritxell. It's the name of this project is called MS Explain, and you have different teams in this project. You have the one like the team of Meritxell who are specialized in explainability, interpretability, and uncertainty. Then you have the team of in Valley who are more specialized in integration of software engineering, but they do also some interpretability methods. And you have the end users, somehow, which are the people, the radiologists, basically. And they have developed a method over the years. And the idea was, okay, now with those methods, how can we make them useful for clinicians? And it's where we joined the team. So we got an additional funding and we joined the team. Just so MS-EXPLAIN stands for multiple sclerosis explainable AI, if I'm not mistaken. So what is multiple sclerosis? I think I don't need to explain it to you, but just as a reminder, is a chronic, progressive, incurable neurological condition that is the leading cause of disability among young adults. And MRI can play a key role in diagnosis and monitoring of multiple sclerosis patients. Well, you know, it's very useful, but it can be also time-consuming, can be affected by artifacts, and depending on the difficulties of the case, there can be subjective assessments. So, according to the literature, AI-assisted imaging has shown promise in saving time, reducing cost, and enhancing diagnostic precisions. And also, the hope is that it brings information that may not be visible to the human eye. Okay. So that's the promise. Well, but we know that it's subject to error, which can impact diagnostic reliability. So the idea of the consortium, and correct me if I'm wrong, is to enhance AI trust and transparency through methods they have developed. So methods are here quickly shown. I'm not going to explain them. That's not my forte. But basically, you have a scan, an MR scan, a flare, or MP2H, or MPH, depending on what you want to do. And you segment it using an automatic method. And then you can have, in addition to the segmentation mask, you can have additional information which tells you how certain or uncertain the algorithm is about its results. Okay? And so this is the uncertainty methods, but you have also explainable methods, which for each voxels tell you how much participates to the decision to say it was a lesions or not. So these are saliency maps, for example. So on the top, you have the uncertainty methods, and on the bottom, you have the saliency methods. So how to translate this information into something which is clinically relevant for the clinicians, and how it can impact trust and transparency, because that's the whole objective now. Somehow, AI was created, then deep learning happened, results go high, but you know, transparency goes down, and people are afraid, black box, etc. So the whole story is that explainable AI will help to rebuild this trust and to rebuild this transparency that is missing now with the current algorithm. But is it true? This is still an unknown. And is it really relevant for clinicians? This is unknown. What is also unknown is, for those who are familiar with, recently there was the EU AI Act. So the European Commissions are trying to enforce is enforcing, actually, not in Switzerland yet, but in Europe, how AI should be used in clinics. And you have to provide some information to the person who is using the tool. But how to provide it, no one knows. So this is also a big question open. And so in this project, we had the technical viewpoint, so the view from the engineers, and we wanted to see from using user-centered methods, so design research methods, how we can use this information and make it usable for the clinicians. So, of course, as a design researcher, we use design research methods. And this is an overview of the methods that we applied. We first do site visits and contextual interviews. So those are the interviews I was discussing with you earlier, saying like getting knowledge from the experts to know better the field. Then we do semi-structured interviews and 2 explorative workshops. So as I say, the first one was to understand the project and also identify who are the relevant stakeholders for this specific project. Then once you have identified them, you interview them to get their requirements. And then we did 2 workshops, one to get the patient perspectives and one to understand, once we had all the requirements, how the software, so how to integrate this data and the architecture that should be behind. So while site visits, you might recognize some of the people there. So we were in Basel there. I think there is Natalia here, Alessandro there. This is not you, no? No, this is the person group. Anyway, we went there and discussing with stakeholders, with experts in the field. We were able to draw the stakeholder power map. So basically, here this maps tells you how your stakeholders are placed in the power game somehow. So because the people who are more powerful, if you co-create together with them, and the one who are least powerful, they will have somehow more weight, and you need to make sure you balance this. So in this case, for this particular project, we are talking about AI. So of course, there is different stakeholders, the engineers, the developers, the neurologists, the radiologists, the patients, and the Swiss medics, TCs, insurer, hospital law. And you know they are spread in a graph where you can get the one which are the most affected on the top. On the x-axis is the one who are the most interested in the technology. And on the z-axis is the one which are the most powerful. And you can see that, of course, the patients are the one we ask the least and who understand the least what's going on, but are the one who are going to be the most affected by this decision to use AI in the medical field. Neurologists and radiologists are the one who are going to use it, so somehow they understand a bit, even though it's not their specialty. But they are very interesting to have it somehow because for them, they see it a way to help better their patients. And then you have the engineers and developers who are the one who knows the best, but at the end who will be the less affected by the technology, unless they get as a patient. Then you have the one who have the most power, and these are important ones because they are the one who decide actually whether we will be allowed to use the tool and if there will be enough money to buy the tool. So you need also to take into account when you create a technology. And yeah, we always place them in the middle as designer researcher, as people who try to translate and to mediate all those different stakeholders. So once we had this map of stakeholders, we did interviews of them. And the idea of those interviews was to understand how trust and transparency are defined and experienced by each stakeholder. So this is the result of this study. So it's a preprint paper, not yet accepted. And the methodology, we did different phases of interview with different stakeholders. So we did interview radiologists, engineers, domain experts, was like ethicists, people in law, designers, and also we did a workshop with patients. And what is interesting and what we find out is that actually people do not experience trust and transparency the same way, and they do not expect the same stuff for trust and transparency. So when you want to deploy a tool, you need to ask people in law, okay, is it okay? Yeah, but I did not expect that. So oops, fail. So the conclusion of that is that when you do that, you need to make them to reconcile all of those notions of trust and transparency to be able to produce something which is valuable and which will be accepted and adopted by them. So at this stage, we had this idea, trust and transparency, not the same, and we had this, the methods developed by the consortium. So what we needed to know is, okay, how we get all those information together. And in terms of design process, there is this famous scale from James Garrett, where you start at the bottoms. We need first to get the user needs and the objectives. So we did that by semi-structured interviews, and we did a little bit of preliminary user testing with the data we had from Mary and Natalia. And then we need to know what you have to put in the software, so the content requirements, and how to put it together. You cannot put everything together and it's going to work. So those are the next steps I'm going to tell. And for that, we used called the card sorting study. So as I said, the objective of this study was to define the requirements and the architecture for this particular application. And we did it we're using some radiologists, engineers, designers, sociologists. And what you need to prepare in advance are the cards. So there is different type of cards. There is the one which is about regulations. So what people need to see according to people making the law. Then what the clinicians want. So those are the pink one. Then what the engineers can provide. Okay, so they can provide, in the case of multiple sclerosis, they can provide algorithms to segment white matter, to segment cortical lesions. And then they can provide also methods to tell you how successful or how uncertain the algorithm is, and why this is the case. So this I already went through, so maybe I'll go a little bit further. Yeah, maybe here to zoom on those cards of the uncertainty. And actually, what you can see is in the case of multiple sclerosis, there is two different paths. There is when you need to diagnose your patients. Does this patient has multiple sclerosis or multiple sclerotic mimic disease? And once the patient has multiple sclerosis, you need to follow him up. So how how the disease is evolving, and this is a follow-up scenario. And what we wanted to know on top of how to put our software architecture, what was relevant in the different scenarios. And that's why in those cards we put like this bottom part where the clinicians put, okay, this is only for research because there are also researchers, but it doesn't make sense in clinic so far. And this is for the diagnosis and the follow-up. So they have to choose. How it happened, first you discuss the card. You say to make sure people understand the cards. And this is a very important step. Then you ask the people to label. So as I say, by relevance, research, diagnosis, follow-up. And then you sort it. Saying like this goes there, this goes there. I know this should go there according to that, and etc. What happens next is that you collect the data. We do, so to analyze the data, we do affinity diagramming. I'm not presenting it today. Happy to come back to present you that later. But you get a software architecture. So what to show when and for which purpose. And then here you can see the different cards. It's not the same color, sorry, I need to change that. But yeah, some are required at this stage, some are required at this stage, and etc. And yeah, some learnings from this workshop. Clinicians don't understand the terminology uncertainty. Doesn't make sense, so they want that we use the term certainty. They want to be certain, which makes sense somehow. What was surprising and very interesting is that they were very interesting in knowing the reason why the algorithm was certain. And then we spent some time working on this part. So I don't know, the type of lesion it is, the type of intensity, and etc. I'm not talking about patient level and etc. No, it's too much detail. That's it. From that, we do a wireframe. So we create the software, but just say like this element will go there, this element will go there, this element will go there, and then we can design them. So these are the first software design version, and of course this has not been tested, so not sure it's what is expected, to be honest. But you can see on the top, of course, the scan, the data of the patients, the different scan, and here on the completely left, the automated output and how it could be presented to help the clinician to decide whether you go further with using this algorithm. What is not decided is really like, okay, how to present this uncertainty level. So we are still working on that and going to test it. So yeah, we are at the stage where we are finalizing the design. And now we need to know, okay, does it impact trust and transparency? Because this was the objective. And does it meet different stakeholders' needs? So that's next studies which are coming. And at the end, what we will get is, of course, some design recommendations for people in this field wanting to implement such a tool. And also in terms of, okay, how clinicians want to have it, but also how you can translate what was dropped by the Europe on the regulatory purpose and how you can actually implement it into your software. What time is it? So here we are at 40 minutes. Should I stop? Okay. So
how long is the report?
20 minutes. So
maybe we'll leave some time for questions.
So thank you for your attention. And if you have any question, I'm happy to answer.